all of you are hearing lectures and deliberations from the learned speakers, and all of you also are from this field and very expert in your own domain. So when I was invited, I thought that in the galaxy of the learned audience, it would not be justified for me to speak on the subject in detail, because all of you know the subject perhaps better than me. So I thought that why should I not tell you a story to give a kind of relaxation to your mind, which is by this time is filled with all technical juggleries, technical advancement, technological advancement, all this. So I thought
registration code.
a glorious past, a story of the dominant present and story of the future of what? Of our community. Our community means those who belong to this waste and wastewater management and water management, these technocrats, it is our story. What we were long ago, when there was no any written scripture that time, what we were there, how did we operate all this wastewater and water management. So all these are very fascinating phenomenon to know. So I thought that why on this occasion I should not take the opportunity to describe you with my little knowledge what we were long before, what we are today, and what we want to be in the near future. Now let's start my story. The name of the story is evolution. Evolution of this water and wastewater management. As you know that as an Indian, always we have recognized the importance of safe water, and we have continuously adapt our practices to meet the growing population demand and public health needs. And this has laid down the foundation for today's efforts to ensure universal access to safe and sustainable drinking water. Evolution of wastewater management story is not very different from what it was about water management. India is from the sophisticated drainage system, as you have seen in Indus Valley civilization, to modern days smart management, and we are going to employ many advanced techniques in modern days like biological membrane and many other technologies. The focus we had in our past days was based on its disposal and drainage, but now the focus has changed to its treatment and resource recovery, recycling, and obviously sustainability. This is now in my slide. Actually, I have tried to divide the time zone in different the time frame into different time zones, and based on the span of the time zone that has fallen in the category of different civilization. Likewise here, around 2600 to 1900 BCE, that falls under Indus Valley civilizations. That pictorial view you are noticing here. This is the well in the same civilization, and this is the drainage system in the same civilization. Now, when we talk about the water and wastewater management, what we notice that public and private wells, that everybody we know that was very eminent in that time. Drains were covered. Why it was covered? To avoid contamination. And obviously, you know you have heard the name of Great Bath of Mohenjo-daro, which is a huge, large bird, and that type of bird used to promote hygiene and sanitation. However, one lacuna or limitations what we noticed that time, that no chemical treatment perhaps existed that time, and source was highly advanced. This is perhaps the world's earliest urban sanitation system and demonstrate a remarkable understanding of public hygiene. As I told already, that well-planned underground drainage system in cities such as Mohenjo-daro and Harappa, almost every house had a bathroom, and that bathroom was connected to drains. The brick-lined sewers were covered, and that used to run along the streets. Soak pits and sedimentation chambers were also present that time, and obviously the reason is to remove solids. Wastewater was disposed of outside city limits, as we do in the present days. Then comes Mohenjo-daro, and you know that Mohenjo-daro, all of you know that presently it is in Larkana district of Sindh Pradesh in Pakistan, but that time it was undivided India, so that was that India. That is one of that Indus Valley civilization, because the civilizations was found on the river bank of the Indus. So this is one of the world's earliest examples of urban sanitation and wastewater management. As I told you that every house had access to well. Drainage system was made of baked bricks. Baked bricks means burned bricks. Wastewater was carried through underground drains and disposal areas, and the great bath size here it has been given, and that was waterproof with bitumen. And that demonstrates that advanced knowledge of water storage and hygiene. Then comes Harappa. Harappa, you know, that is in Punjab province, and that is actually on the right bank of the river Robi, and this Robi is one of the tributaries to Indus River. One of the 5 tributaries to Indus River. So that civilizations grown up there, and that has a feature. What feature? Numerous wells and a well-planned drainage network, brick-lined drains that carries wastewater away from the residential areas. So that was the purpose, that all the residential areas were built up in such a way that drains were brick-lined, and that went beyond that boundary of that residential area, so that wastewater can be taken out to the outside, and inspection chambers allowed cleaning and maintenance tanks. Then come Dholavira. Dholavira, you know, that is located in Gujarat, and nowadays actually we talk about rainwater harvesting and all these things. So water conservation now actually talk of the day, but that time you imagine that Dholavira was the greatest example of water conservation, and that where it was located, you know, that water scarce area that is in Kutch of Gujarat Pradesh. So there actually it was located, and huge reservoir was constructed to collect rainwater and seasonal steam flow. So not only rainwater, when actually that excess steam water was there, that was also to be stored in that particular reservoir, and channels and bunds were built so that excess water to be diverted into the storage tanks. And archaeologists, they have identified that multiple interconnected reservoirs. So one could take advantage of the whole reservoir system. They were well connected with one another. Now after that, so when this industrial civilization one part. Then after that one era, I have marked it from 600 CE to 1500 BCE, and I have named it as a Vedic and early historic period water management part. So here, this particular text has helped me to have this information. That was Charak Samhita and Sushruta Samhita that mentioned that all these methods relied mainly on natural and household level purification. So now we talk about collective purification, but here actually it's based on household level purification and mostly dependent on natural resources like sunlight or oxygen available. Ancient texts such as Rig Veda and Atharva Veda that also talks about the purity of water. Water purification methods was what that includes filtration through clothes that we have seen in our childhood days also, storage in copper vessels that also we have seen in our childhood days, exposure to sunlight, boiling of water that still is prevailing, settlement developed in ponds that also technology is also pertinent today, settlement developed in ponds, tanks and stepwells for water conservation. Then in the same period, when we talk about wastewater management, then Arthashastra tells us that sanitation regulation and penalties were introduced in this particular era. When somebody used to pollute public spaces, he was fined. The penalty was imposed upon him. So that was the, nowadays actually we are talking about regulation, penalties, all these things, but that time also it was present. And so mentally aware we were and developed we were that we thought that until and unless penalty was imposed, nothing could be done. So that penalty was imposed that time also if anybody used to pollute public place. During the Vedic period, settlement, that became more rural and decentralized. That also obviously that obviously settlements were more rural and decentralized. What are the features? Features were that time we used to see soak pit, natural infiltration. Soak pit means always natural infiltration. Disposal of wastewater into agricultural lands. Nowadays also it happens. Reliance on rivers, ponds, tanks for water supply and wastewater dilution. So that time actually, nowadays also we do after treating from, nowadays actually it is a zero BOD discharge is talked about, but in my period of working that time 30 milligram per liter was the limit. So with that we used to, we were allowed to discharge to the river based on the condition that it will be diluted, rest of the amount, the 30 milligram liter will be diluted into the river. So that time also this concept of wastewater dilution that was also available that time, and emphasis on cleanliness in religious and social practices that obviously now many persons we talk we raise questions why cleanliness is required when any religious practice is done. That is the actually kind of sense of hygiene is imparted through that. So that cleanliness impulse or sense of hygiene through this type of practice that has been also very much present at the time. Then came Mayur and Gupta periods. That is around, I have drawn it between 505 CE to 320. Technologies was developed or emerged in this time to generate huge quantum of wastewater. This is the canal. The colonial period, before independence. In this period, what we notice that scientific municipal wastewater management, its beginning was noticed in this period. Modern water management concepts from Europe that was borrowed. Major cities such as Kolkata, Mumbai, Chennai established pipe water supply. Flow and filtration was also noticed. And I can remember that one such flow and filtration was available in our Srirampur side. That presently I don't think that is available there, but in our times also that was available. And other places also you know that Tala Polta that already you know. Chlorination began in the in early 20th century. One disinfection program was also introduced, that is chlorination. That also started in this time only to control waterborne diseases. Now, what is the type of water management? That was purely conventional type. You are very familiar with, and the methodology was coagulation, flocculation, sedimentation, filtration, disinfection. National program was also introduced to save drinking water in the urban areas this time. That's why as I told you that piped water supply started in major metropolis that time. But this time, up to this time, groundwater became a major source of drinking water. In case of wastewater management, what was the importance? This is the beginning of engineered wastewater collection system in India. What are the driving factors? Recurrent outbreaks of cholera, plague and typhoid. Need to improve sanitation in rapidly growing cities. As there was recurrent outbreak of cholera and plague and typhoid, so people were very afraid and they wanted to have some way to get out of these issues, and that's why wastewater collection system. So she new beginning in India. And what the major developments what you notice in this time? Underground sewage system already started during this period, where it was started Kolkata, Mumbai, Chennai. Not only underground sewage, pumping station also, pumping and sewage disposal station also was started during this period. And during this period only, sewage farming also
hydraulic civilization
took place.
Water storage, pricing, rainfall measurements.
Now, after that, all of you know that in 1947 we got independence. In this period, I have divided the total time in two frames. One is 1947 to 1980, just before introduction of the modern technology, etc., and 1980 onwards. Then, in this 1947 and 1980, in the water management scenario, what we have noticed is conventional water management plants in urban areas, adoption of standard management processes, coagulation, also available. And during this period, large dams and reservoirs were constructed. Piped water supply in major cities, their domain were expanded. Various rural water supply programs started, particularly in accelerated rural water supply programs. Major characteristics of pollution in rivers, lakes, water sources, strengthening of regulatory institutions such as Central Board and State Pollution Control Board, launch of major environmental programs including compaction packs, mitigation, particularly in East India, arsenic mitigation, expansion of laboratory-based water quality surveillance, greater emphasis on food protection and environmental sustainability.
টাকা কোথায়?
Then post-independence period in 1980 to 2000, water management, what we see, the technological development, pressure filtration system, though it was introduced in before 1980 only. However, it was very much dominant in this era. Activated carbon treatment, improved disinfection practices, early adoption of membrane-based technology in specialized applications. And what was the outcome? Increased awareness of drinking water quality standard, improved monitoring of physical, chemical, and biological parameters, foundation laid for modern water management technologies adopted after 2000. Regarding wastewater management, priority was given to sanitation infrastructure. Challenges, what challenge we had that time? Rapid urbanization, outpaced infrastructure development. Most cities lack adequate sewage treatment capacity. And development, what you notice, that expansion of sewage system in metropolitan cities, establishment of sewage treatment plants, adoption of conventional biological treatment technologies like activated sludge process, trickling filters, oxidation ponds. And our focus was reduction of pollution in major rivers, monitoring of industrial effluent discharge. And in this era, the landmark events are formation of Central Pollution Control Board, launch of the Ganga Action Plan in 1985. What technological advances we have, large STPs built across major cities, introduction of upflow anatomic such blanket, UASB, reactors, waste stabilization ponds, anaerobic digestion system. Then come the modern India where we live in. In this particular era, that large-scale water management plants were established across country. Conventional management process became standard, coagulation, flocculation, standard filtration, disinfection, as I told. National programs expanded access to safe drinking water in rural and urban areas. Groundwater became a major source of drinking water. Till this time also, early part of this time, we had groundwater as the major source. Then current water management technologies include membrane filtration, UV and ozone disinfection, desalination plants, advanced oxidation process, real-time water quality monitoring using sensors and AI, water recycling and reuse systems. Now, modern India, major initiative includes, as all we know, Jal Jeevan Mission, Atal Mission for Rejuvenation and Urban Transformation, river cleaning projects such as Namami Ganga program. Major drivers in the wastewater management was urban growth, water scarcity, strict environment regulation. The policy initiative, what policy initiative? Namami Ganga program, Smart City Mission, Atal Mission for Rejuvenation and Urban Transformation. And focus was waste recycling and reuse, energy efficient treatment, resource recovery. Advanced technology, what have been introduced during this time: sequential batch reactor SBR, membrane bioreactor MBR, moving bed biofilm reactor MBR, advanced oxidation process and UV disinfection. Now we have completed up to this time. Now the emerging trends are circular economy approach, zero liquid discharge in industries, digital monitoring and automations, AI and IoT based plant operation, nutrient recovery and biogas generations, decentralized wastewater treatment system DWAT. Our current goal is management of all urban wastewater, reuse for agriculture, industry and groundwater recharge, river rejuvenations and environmental sustainability. Now, during this journey of water and wastewater management, we have seen that there is a transition from natural purification and sophisticated ancient water management system of the industrial civilization to modern technology-driven treatment plants, and ultimately to economic growth and environmental protection. And ancient India focused on drainage and disposal, but contemporary India emphasizes treatment, recycling, resource recovery, and sustainability at the beginning already I mentioned. And future wastewater management is expected to be driven by circular economy principle, energy neutral treatment plant, and large scale water use and address growing water scarcity and environmental challenges. With all this, let me conclude. Thank you all.
Thank you. Thank you very much, Dr. Bhattacharya, for your nice presentation. You have started with Indus Valley civilization. You also discussed Vedic period. You also discussed Maurya and medieval period, then colonial and pre-recent time, and then modern time. You highlighted very many features of that time, including drainage system, soak pit-driven construction, rainwater harvesting, all these things. Initially, it was a centralized, then again become decentralized. British era, when came the emphasis for centralized system. Modern India, we are talking about centralized as well as decentralized approach. In the rural areas, we are depending on decentralized approach. Also in urban areas, decentralized approach are being also appreciated. So these issues that we have discussed, hopefully the audience will raise some question. So this paper is now open for discussion. Any questions, sir? Madam, any question? Dr. Buddhadev Bhattacharya's presentation, if you have any question, if you want any clarification, you can raise. Ashish wanted to say something. Follow. Now, mic to the Ashish. Yes.
Actually, Dr. Bhattacharya, whatever our chairman from Mavada told and also you have shown chronologically from the ancient era to modern period. Although that is the how the advancements in wastewater technology changes the rising demand of the era. Just I can wanted to know how these things, whatever they are prevailing now, with the rising urbanizations and the various climatological changes factor, whatever the prevailing wastewater management system, does it better after 15 to over 20 years, that is in today's 2026, as it better to 2040? Can you just this is my actually query, and just I am asking you. So if you can give some hints for that, how that quick, although you have also mentioned AI technology,
Yes.
so can you give some glimpses after 20, 25 years? What will be
Yes,
the
yes.
situation on
Yes.
wastewater management?
Thank you. Buddha.
Already, Mr. Ashish Dattachandri is has raised very good questions that what it would be. Actually, thing is that it is not that story. I also do not know what would be after 20 years, 40 years after. But some emerging trends, as you see that that AI and IoT-based planned operations, nuclear recovery. So all this area will be will get more importance in the coming days. So based on that, technology will evolve. So right now, I cannot say that what technology will come after 40 years because I am not a future predictor.
Right.
But thing is that definitely technology will come to mitigate all these issues.
Okay. The issue is that our wastewater management system or water supply must be sustainable. In wastewater management system, Government of India has categorically said that we have to recycle or reuse our wastewater. West Bengal government recently published the policy where it has been said by 2030, 25% of the wastewater after treatment will be used. And this will be increased by state. Whereas by Namami Ganga, they said that you have to do the needful of 50% use by 2030. So as much as possible, this should be utilized. Government of India Power Department has said that all thermal power plants must take treated sewage. If the sewage treatment plant is situated within 50 kilometers from the thermal power plant. Sludge. Recently, advisories has come from Government of India that sludge is to be utilized, of course, after proper treatment as a manure. So therefore, these are coming forward so that we can earn revenue out of that. So all flagship programs are now highlighting circular economy, cost benefit, involvement of business mode, development of entrepreneur, so that these management systems are valued. Thank you very much. The next presentation will be with respect to wastewater treatment technology, and basically these are advanced technology that will be presented before you by Subroto Bhattacharya of SFC Environmental Technologies. SFC Environmental Technology has developed CTEC technology. This is for sequential batch reactor, SBR. In West Bengal, 9 SBR units are being operated at present. More SBR unit would be coming up. Only thing we are with respect to SBR, we can say it required very less amount of land. Recently, SBR will be constructed with multi-story building with less space. Another advantage is that the SBR technology can conform 100% with National Green Tribunal technology. So therefore, Mr. Subroto Bhattacharya will be definitely highlighting SBR technology along with some other associated technology that will be very much beneficial to you. Thank you very much.
Good afternoon, everyone. Good afternoon, everyone. I am Subroto Bhattacharya representing SFC Environmental Technologies Limited. We are basically a technology provider for sewage and industrial effluent, but more into sewage. So we are into liquid waste as well as into solid waste also. Sir has just introduced us. See, you can see this, we are into municipal sewage treatment. Mainly for municipal, we used to call it, we are specialized in SBR, sequential batch reactor technology. My earlier speaker, Dr. Bhattacharya, he already narrated from the ancient time to the modern time how the technology has improved day by day. So we are into the latest era. So this sequential batch reactor technology, we call it as C-Tech. C means cyclic activated sludge technology. It's a name, C technology. And for that we have SBR, C-Tech SBR. Then we have advanced energy efficient system like turbo blowers and solar sludge turning and tilling machine, like Dr. Majumdar also told that nowadays the guideline for sludge treatment has already coming up. Already Government of India, CPHO, they have published the report and the guideline also. Then we have the recycling and reuse model. For that we have fiber disc filter, like it is membrane based, then membrane bioreactor, then submerged ultrafiltration, as well as CCRO. I'll just go through at a glance in my later slides. And we are also into municipal solid waste. So I am not taking that part into, because this session is for liquid waste management only. So in solid waste also we do the entire, in Goa we are doing, for entire North and South Goa we are doing the entire solid waste treatment. We are generating power as well as, I mean, from gas and power from organic waste. SBR, in SBR market we are mostly 80% market share we have, and we have more than 1250 plants across the globe. This I'll just skip all this. See, this slide I am just showing, I don't know whether you can, it is visible or not. See, just I wanted to, because Namami Gange is a one part Government of India, it has taken care from, and the Ganga, it covers basically mainly, earlier it was for 5 states, now it has been expanded, because not only the mainstream of the Ganga, now Namami Gange, they have taken care of other tributary and distributary which are also meeting river Ganga and all. So in all 5 states, just I wanted to state that Uttarakhand, then UP, Uttar Pradesh, then Bihar, Jharkhand and West Bengal. And we are pleased to inform you that we have plant at Uttar Kashi at the starting point, mostly you can say at the starting point, and we have plant at Bajbaj at the end point also. Now coming to this West Bengal, we have 10 plants in West Bengal as on date operating, and another 5-6 plants are also under construction. These are mainly with KMDA, PHED, and Kolkata Municipal Corporation, KEIFE, all. These are some pictures. This is one, yes, Dr. Majumdar has already told that we are doing now the double story STPs. So this is one of the double story STP, 23 MLD. So there are 4 SBR basins. So at ground 2 and another 2, and you can see the inlet is at 23 or 24 meter above ground. So if you go to this, you can visit. This is in Sonarpur, Rania, constructed by KEIIP. Now it has name is changed to KMC Sharp. So you can see the entire city. And another 2 projects are already under construction under Adi Ganga project. So there will be one 10.5 MLD and another will be 11.5 MLD. Both are also double story STPs. So this is a clear water I have just shown in the, this is the Ranaghat projects. This is a typical process flow diagram, you also are aware, but I will tell. The raw sewage comes into the wet well. Before that we have coarse screen, then wet well, from there it pumped to the inlet chamber, then fine screen, so where 6 mm specifics are there, and then okay, grit, for grit mechanism, grit removal, and then primary clarifier may be present or may not be. It depends upon the your biogas generation requirement or not. Then it comes to the SBR part, and SBR, then chlorine. We, where means for disinfection people are using chlorine, or nowadays UV is also coming up, ozone maybe, and then you dispose it. This is a simple process where you are generating power. See, now I will come to the basic of SBR. SBR means sequential batch reactor. it is not a continuous process, it is a batch process. Means batch process means you take the sewage into one tank, then we call it filling and aeration. It is all controlled by PLC. Your gate opens, then your sewage comes, enter into the tank, where filling as well as aeration goes on. Then filling and aeration both stop. After that, the sludge settles down at the bottom of the tank. Then that is called settling, and then the decanter, there is a mechanical device which decant means what we know, we can take the supernatant, that is called decant. So the decanter then moves, it take out the water from the top to a certain level, 2 meter or 2.4 meter depending on the design. Take out the water, then again that whenever decantation process is finished, then again that batch will come. Now for that, basically we need minimum two SBR basins, because your sewage will always come at a continuous from the pumping station. So when one tank is in filling aeration mode, other one will be in settling and decantation mode. So when that settling and decant completed, that tank will be ready for filling aeration, and this one will go for like this sequence. So there are minimum two, then 2, 4, 6, 8, multiple, even number. So depending on the plant capacity. This is basically the decanter I can show. This is the decanting mechanism. This is a mechanical decanter. It moves. Normally it is like that, and then it moves down from the top to it touches the water and take the water out. This is a diffuser system, underground diffuser system. Air is supplied to the diffusers. This is a typical, basically it is a fully process PLC controlled system. So this is a typical diagram I have shown. Now coming to this new products, as we told, now earlier basically we used to, and even still now we are using this normal roots blower, but we have developed this turbo blower which operates at 20,000, 25,000 RPM and is for minimum power consumption, as well as you need not to have any foundation for this. This is the latest development. It is a fiber disc filter. Like we know about sand filter, pressure sand filter, rapid gravity filter. These are fibers are there. Fiber disc. It is for tertiary application. We take the water from, because if you know the National Green Tribunal guideline is 20 TSS, 20 milligram per liter. But if you want to have 10 or 5 or less, so then you can use this for tertiary application. These are fiber disc filters. See, this is our new membrane area. We have tie-up with DuPont. DuPont is a famous brand in membrane. So we have Memcore for submerged ultrafiltration and membrane bioreactor. And membrane MABR, there is a membrane aerated bioreactor, and we have a closed circuit CCR. I'll just quickly go into this. Sorry. This we have this one. This submerged ultrafiltration, basically, you know, ultrafiltration is always, we earlier used to know the pressurized ultrafiltration, but this ultrafiltration is for submerged, means it is submerged into the tank, and then you are not pressurizing the effluent from inside to outside. It is from out to in, and it will just suck the liquid. There is all that for tertiary treatment, for reuse and recycle as per the requirement of the industry. These are the membrane sizes and all. This is membrane typical MBR treatment. Like you are basically you get more stringent parameter if you need, or industrial parameter guideline if you have to follow. Then you can go with the membrane. Membrane, you always know, we put the membrane into the tank, and then there is a permeate pump which sucks the liquid through the membrane, so you are getting more clean water. MABR, basically, I'll just show this one. See, nowadays what we are facing, many ULBs and government organizations, they are facing that the earlier we used to have the old plants. Now, and we should not dismantle. It is not the better to dismantle and then go for a new plant. It cannot be possible economically also viable. It is not viable. So what we are doing, we can, to achieve the new parameter, latest guideline of the government of India. So we can put this, there are laces, like these are also like some, you can develop the media inside the membranes, and then you can increase the capacity of the plant, and as well as you can get the better outlet parameter. Basically, nowadays nutrient removal is also a major part. So this is mainly used for the nutrient removal as well as BOD removal also. This is a closed circuit RO. See, RO, earlier we used to know the normal RO. So normal RO, it can give you the efficiency of 60 to 65%. And then if you want to go for another more efficiency, then you have to, in series, you have to go one by one. But this closed circuit RO actually it gives 80 to 85% efficiency, recovery rate. So is a, within the system it recirculates. That is called closed circuit RO. This is, we talked about the sewage, and now the liquid part. And the solid part, basically in sewage treatment, the solid is generated as a sludge. So what we do with the sludge, basically the sludge is dewatered through centrifuge or filter press or many other things, but then you are getting only 20% solids. Basically in biological sludge is 1% solids and 99% water. By dewatering, you are getting 20% solids and 80% water. But its handling is very difficult. So with this solar sludge drying system, we are getting nearly 75 to 80% solids and 20% water. So basically it looks like that, and there are many installations in India and coming up with the latest guideline also. So this is for sludge handling system. So thank you, my presentation.
Thank you very much, Mr. Bhattacharya, for your presentation, highlighting very many technologies that you are using for the wastewater treatment throughout the country. This paper is now open for discussion. Yes. Eta ye dao.
Whether FPL technology can be used for liquid waste from the hospital.
Yes, yes, definitely.
Whether it has been used anywhere.
No. We have in India, we have reference in pharmaceutical, then textile and all. Not in hospital, we don't, because what happens, sir, in hospital, if you see, the capacity is very less. Means we are talking about municipal sector, we SBR, we talked about in million liter per day, MLD capacity. But if you talk about hospital waste, only hospital waste, not that entire grey and all, only the hospital waste, the capacity is very small. So definitely you can use, but there is economic viability, because SBR will never tell that you should go for KLD level, means kiloliter per day. KLD, in hospital waste, if you talk about KLD, it is very small. So it will always be economical if you are talking about MLD, means million liter. So if your capacity is more, then it will be definitely, but yes, it can perform. You should have the treatments like physicochemical and chemical treatment you should have. But yes, for your question, we don't have any reference as on date for hospital waste.
Have any study been made on conventional ASP versus SBR, but same concept? Any idea muscle aspect?
Yes, there are reports available long back. All 7 IITs, they also did. The reports are available in the website. Say, ASP and conventional ASP and SBR. Basically SBR, if you talk about SBR, is modified version of ASP. ASP is the mother of all technologies. Now, land, if you consider land, definitely SBR has the lesser space because you are combining simple two things. You are combining the aeration tank and the clarifier into the one tank. So you are reducing the space. And another thing, SBR is having nutrient system like nitrogen, phosphorus. For ASP, you have to have anaptic and anaerobic post pre-treatment to the aeration tank. So you can, in SBR, it is an inbuilt system. So
wastewater. That is BOD value of biomedical milligram per liter BOD average. It is not more than that because blood is also contributing BOD, but the hospital must have a separate biomedical waste. With respect to that technology per se, SBR, I think it is suitable because it activated such process with extended aeration system is suitable for treating biomedical waste. SBR is also suitable. There is no problem. And the last one, that question, but we are now not constructing because we have any technology. Technology is extended aeration system, no doubt. But advantage is there with respect to economy in, electricity power consumption, because they are not editing 100% total basin, filling 100% total basin, filling, then editing capex high. OPEX, ना ये बोलो, ना ये बोलो. Actually, it's true. But if you go in for biological treatment, activated sludge process biological treatment is sewage in Calcutta. We find antibiotic resistant bacteria, and it is very much high near Calcutta Medical College, NRS, RGCOD. That is true. But issue is that the technology that adopted can treat, because you have to bring down to well said. Mr. Moshad, yes, please.
And Mr. By any chance, any of your packages, you will use the latest technology of nanotech, which is graphene or otherwise?
we are using MBR, membrane. So that is basically ultrafiltration, microfiltration, ultrafiltration, nanofiltration. It is there. In MBR, it is basically ultrafiltration, if you talk about. And then we have RO. There is actually after nanofiltration, RO comes. So we have RO also, but that I just told you, not in SBR. Means if you need to reduce the TDS level, then only you go for RO. As per the industry norms, like what is happening now, sir. Now, Government of India, they have made one notification that the power plants or industry which is having within 50 kilometer, if they are having one sewage treatment plant, then they should have take the sewage from the sewage treatment plant and they need to do the treatment, tertiary treatment and use. So that 15% they have to take as per their requirement of fresh water, because now they are taking the fresh water from the river and all. So these plants are operating, like one plant is operating in Nagpur. Is a 200 plant is they are giving the water to Mahajanpur thermal power station, and there are other plants are coming up accordingly. So recycling and then NTPC, they are also going with that. So there definitely these technologies, these modern technologies are coming up with MBR and RO and all.
I asked about the latest one, which is a carbon based field. You using that?
No, 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 no.
Currently studying filtration technology, which means I have a small setup of microfiltration, which is not submerged still. It's a very big challenge for me. Our cleaning of filter with hand washing and cleaning, and wasting so much clean water for cleaning of the filtration for the next lab or testing. So I'm just curious that how this submerged filtration technology you are using is tackling this cleaning and filter fogging thing, odor and fogging thing is managed.
See, submerged, you are using for, means I am talking about the submerged ultrafiltration for tertiary application. Means when your TSS is basically less than 10 or 20 and turbidity maybe around 10 or 20 maybe 20. Okay. Then from that you are getting a turbidity of less than 1. So I am not talking about the raw water. It's like this submerged ultrafiltration. Yes, definitely. We have a plant in Agra. You know Agra. So where they called it is operating from last 10 to 12 years. Okay. They called it, it is for a drinking water. They call it advanced water treatment plant. Okay. Because you know Agra, they have a Jamuna. So Yamuna is a sewage canal of Delhi. So what they are doing, they are putting one, they have one MBBR based sewage treatment plant first, like it is sewage. They are, because BOD you need to remove this. Then for the normal sand filter, they are using this your submerged ultrafiltration. So it's operating from pretty long time, and yes, backwash definitely it is through the suction system, and you have open tanks also and closed tanks also. So these are operating. So if you need some reports, you can keep my card and I can give you some more detail because I have, but this now it will be very lengthy to discuss in depth. Okay, but these plants are operating from pretty long time in India. That was for drinking water. So you know, drinking water you have a more challenge to meet the water quality continuous basis. So that they are doing.
Any more questions relating to Bhattacharya's presentation? আর কোনো প্রশ্ন নেই? তাহলে তোমার আছে নাকি? Now, out of 39 sewage treatment plant getting operated in Kolkata metropolitan area, we have actually 10 SBR running. Activated sludge process, 9 numbers. Trickling filter are working condition in 3 number of sewage treatment plant. FBAS, fixed bed activated sludge, 2 numbers. Facultative aerated lagoon, 2 numbers. And waste stabilization pond, 13 numbers. These are operating today. But more plants are coming on in West Bengal as well as in Kolkata metropolitan area. Mostly this will be, I understand, SBR. Okay. So SBR number will be maximum in future, no doubt. But again, I like to mention that sustainability is considered to be very important. These plants are running mostly under capacity. Except SBR, none of the treatment plants are conforming to NGT standard. Most of the plants are conforming to MOEF standard. That is true. That is true.
SBR NGT.
But to be very frank, actual picture is that many plants are not operating for 24 hours. This you have to consider. Number two, fuel problem. The main pumping station is supplying sewage to the sewage treatment plant. Aerators are in operation. As long as the main pumping station stop supplying wastewater to the treatment plant, aerators are stopped. If you ask them, operator, why you are not running the aerators, they said sewage is not coming. So therefore, where bioreactors are there, if the oxygen we are not supplying, how MLSS will grow? So if you see the activated sludge process MLSS content actual, it is between 500 to 600 milligram per liter. That must be at least 1500 to 3000 milligram per liter. MLVSS 70% to 80%. It should be, but in many places it is even less. So these are certain problems are there about the running of this particular type of plants. Training is required for the operators. These are very much needed, you do understand. So all these issues are important, we do consider, because basic objective is to abatement the river pollution. Hopefully that the concerned department will take the measures to come up with solution and upgrade the operation and maintenance. With this, I close this session. Thank you very much for your patient hearing and participation in the discussion. I convey my thanks to all speakers in this particular session. Thank you very much. We now break for lunch. এইগুলো নিয়ে যাও, এগুলো নিয়ে যাও, এই যে সুব্রত, এগুলো নিয়ে যাও, অঙ্কিতা দত্ত নিয়ে যাও।